Hello everyone, this is our session 6 on trigonometric functions. We had finished with sine rule, cosine rule, projection rule and the applications of those. That is the Heron's formula, half angle formulae and the Napier's analogy. Okay, so we are just going to make a list of all these formulas first and then we'll start with exercise 3.2. Okay. So what is the first one? The sine rule. So let us begin with sine rule. So sine rule is, you can write it here only, A upon sine of capital A is equal to D upon sine of capital B is equal to C upon sine of capital C, right? In one line. Yeah. Which is equal to 2 times of capital R. R is the circumradius, right? After that, cosine rule. So the cosine rule is A square is equal to B square plus C square minus 2 times BC cos of capital A, right? Then B square is equal to C square plus A square minus 2AC cos of capital B and C square C square is equal to A square plus B square minus 2AB cos of C, right? So that is our cosine rule. Okay, then we'll write the projection rule. So we have projection rule. So what is that? A is equal to B cos C plus C cos B, right? That is your projection rule. Then we have B is equal to A cos C plus C cos A, right? And then C is equal to A cos B plus B cos A, right? C is A cos B, B cos A, B is A cos C, C cos A, and A is B cos C, C cos B. This is your projection rule. After this, we have the Heron's formula, or rather the half angle formula first. So let us put the half angle formula. half angle formulae. So we start with sine of a upon 2 is equal to under root of s minus b, s minus c upon bc, right? Then we have cos of a upon 2, which is equal to under root of s into s minus a upon bc, right? This is sine, cos, and then we have tan of a by 2, which is equal to tan of a by 2, which is equal to under root of s minus a, s minus b, s minus c divided by s into s minus a. Okay, this is your half angle formula. Then we have the Heron's formula, which is for area of triangle. So let's just write that also. Area triangle ABC is equal to under root of s into s minus a, s minus b, s minus c, right? Okay. Then we have the Napier's analogy. Okay. So let's write the Napier's analogy in the next page. Napier's analogy for half angles again, you can say. So it is in triangle ABC. Okay. We have tan of b minus c upon 2 is equal to b minus c upon b plus c multiplied by cot of a by 2. Then tan of a minus b upon 2 is equal to a minus b upon a plus b multiplied by cot of c by 2. Tan of c minus a upon 2 is equal to c minus a upon c plus a multiplied by cot of b by 2. Okay, this is your Napier's analogy. So we have all the formulas with us. Let us begin with exercise 3.2. Okay. Now the first question is simple. You just have to do the conversions into Cartesian and polar coordinates. So let us begin. I'll just do one of them for you. The first question, find the Cartesian coordinates of the points whose polar coordinates are root 2 and pi by 4, right? So root 2 and pi by 4. Polar coordinates are given. So this is r and this is theta, right? How do we find the Cartesian coordinates? X is equal to r cos theta and y is equal to r sin theta. Okay. So here we'll directly substitute. X is equal to root 2 cos of pi by 4. Okay. And y is equal to root 2 sine of pi by 4. What is cos of pi by 4? Cos 45, 1 by root 2. So if we substitute this, we'll get 1. Here also we'll get 1. So the coordinates, Cartesian coordinates are 1, 1. Okay. Let's do the next one, question 2. Okay. So I'm taking question 2, the second one. The polar coordinates 0, half are given to you. So we have to find r. So r is equal to under root of x square plus y square, which is equal to under root of 0 plus half square, right? So we get the answer as half. R is half. Now how do we find theta? So we know x is equal to r cos theta. Any one equation we can use and find the value of theta. So x is 0, okay, which is equal to half cos of theta. So we have cos theta is equal to 0. Now which value of cos gives us 0? It is cos of 90. So theta is equal to 90. So your r or equal to pi by 2. So we can write the polar coordinates over here will be half comma pi by 2. Okay. These are the polar coordinates, question 2. Let's go to the next one, question 3. Now what is question 3? In triangle ABC, if A is 45 and B is 60, find the ratio of its sides. A is 45 degrees and B is 60 degrees. Okay. So they've asked us to just find the ratio of the sides. So to find A is to B is to C. Okay. Solution. We'll use the sine rule. So sine rule is A upon sine A is equal to B upon sine B. Right? So let us use this rule and find the ratio A upon B first. So therefore, A upon B is equal to sin A upon sin B. Right? So what is it that we'll get? Sin A is sin 45. Right? And sin B is sin 60. So what is sin 45? We'll have A upon B is equal to 1 upon root 2 sin 60 root 3 by 2. So we are getting 2 upon root of 6 as the ratio of A upon B. Now we have to find the ratio of B and C. So first let us start with projection rule. Projection rule for C ratio is given by projection rule. What is projection rule? C is equal to A cos B plus B cos A. Right? So that's pretty simple. C is equal to, what is A? We have 2 cos of B, that is 60, right? Plus B, that is root 6 into cos of A, that is cos of 45, right? So C is equal to 2 into cos 60 is root 3 by 2 plus, sorry, cos 60 is half, not root 3 by 2. Plus root of 6 multiplied by what is cos of 45, 1 by root 2. Okay, so what we can do is this can cancel here. Yeah, so we have 1 left over there. 1 plus root 6 can be written as root 3 into root 2 upon root 2. So root 2 cancels. We have C equal to 1 plus root 3, right? So what is A is to B is to C now? It is 2 is to root 6 is to 1 plus root 3. Okay, this is your ratio of the 3 sides. Okay, let's go to the next one, the fourth question. We'll start with question 4. Now, what is question 4? Let us read through it. In triangle ABC, prove that sine of B minus C upon 2 is equal to B minus C upon A cos of A by 2. Sine of B minus C upon 2 is equal to B minus C upon A multiplied by cos of A by 2. Okay, so let us begin. Now I'm going to start with the right hand side first. Okay, so RHS is equal to B minus C upon A cos of A by 2. Okay, I'm going to use the sine rule. So what is the sine rule? A is equal to 2R sine A. B is equal to 2R sine B. And C is equal to 2R sine C. Okay, so we'll substitute these in our RHS. So what is RHS equal to? One second. What is your RHS? So it's B minus C upon A. So B is 2R sine B, right? Minus 2R sine C, right? Divided by upon A. So 2R sine A. Okay. And we have it multiplied with cos of A by 2. Right? So just shift this multiplied by cos of A by 2. Okay. So 2R will cancel out. We will have sine B minus sine C upon sine A cos of A by 2. Okay. What can be right about sine B minus sine C? We have done these formulas before. So sine B minus sine C can be written as okay. So sine of B minus C can be written as we have the identity sine of A minus sine of B, which is 2 sine of A minus B upon 2 cos of A plus B upon 2. So we'll write this as sine B minus sine C can be written as 2 sine of B minus C upon 2 cos of B plus C upon 2. Okay, this is your numerator. Denominator can be written as it is the denominator is sine of A. It can be written as 2 sine of A upon 2 cos of A upon 2. Okay, multiplied by the cos of A upon 2, which is already there in the question. Okay, so this will cancel out. We're left with 2 will also cancel out. We're left with sine B minus C upon 2 cos B plus C upon 2 and sine of A upon 2. Now observe this, sine of A upon 2 is equal to sine of pi minus A upon 2, right? We have this. Now pi can be written as addition of all the three angles, A plus B plus C, right? So, or even better, we'll put it in the form of 90 degrees, that is we can write this as sine of A minus 2 is cos of pi by 2 minus A upon 2, right? Cos of pi by 2 minus A upon 2, which is cos of 90 minus A upon 2, B plus C upon 2. Okay, so sine of A upon 2 is cos of B plus C upon 2. Okay, so this is your rough column. We'll substitute this here as sine of B minus C upon 2 cos of B plus C upon 2. Denominator will also become cos of B plus C upon 2, right? So this will cancel out and you are left with sine of B minus C upon 2. Is that our left hand side? Let us check. The question was, prove that sine of B minus C upon 2 is equal to B minus C upon A cos of A by 2. we had started by the right hand side, and have we reached to b minus c upon 2? Yes, so this is equal to our left hand side. Therefore, you just repeat the question, sine of b minus c upon 2 is equal to b minus c upon a multiplied by cos of a by 2. Okay, this was the sum, question number 4. Okay, let us begin with question number 5 now. What is question 5? Let's check. Okay, the question 5 says that 2 times a sine square c upon 2 plus c sine square a upon 2, okay, in a bracket, is equal to a minus b plus c. Okay, so left hand side we'll start with. Left hand side is equal to 2 bracket a sine square c upon 2 plus c sine square a upon 2. Okay, what we'll do is we'll use the Ron's formula for half angles that we know. So we'll put 2 outside. We'll put your bracket here, a as it is. Now it is sine square, so there'll be no root sign. In the formula, if you see, let's go to our first page and check the Heron's formula first. So the first page, oh sorry, this is, okay. So the Heron's formula for half angle will be under root of, the root sign will not be there, so let us begin. S minus, we'll put it in a bracket, so S minus B, S minus C, right, upon BC. Sorry, S minus B, S minus A upon AB, because C is the angle, plus C as it is, in brackets, S minus B, here S minus C upon BC, and the brackets close. Okay, so what do we get? Here A cancels out and here C cancels out. Denominator is same, so we'll just write the numerators together. 2 outside. In the bracket we have S minus B, S minus A here, plus S minus B, S minus C here. Okay, yeah, and we put the denominator. Clear? Okay, now if you observe in the numerator we have S minus B common, so we'll write that as 2 S minus B common. Okay, you can put the denominator outside as it's a common denominator. S minus B is common in the numerator. What are we left with? S minus A plus S minus C. S minus A plus S minus C. Okay, so I'll substitute the value of S in the second term. What will be the value of S? It is semi-perimeter, right? So A plus B plus C upon 2. We'll keep the first term as it is for now. We'll solve this one. So we have 2 times A plus B plus C upon 2, right? Because this is 2S minus A minus C. Okay, and the bracket closes. So 2 upon B as it is. S minus B over here as it is. In this, what can we write? This 2 and this 2 will cancel. So we will have A plus B plus C minus A minus C. So what are we left with? Minus C cancels out, minus A cancels out. We are left with only B. Okay, so we have 2 upon B, S minus B multiplied by B. So this will cancel out and we are left with 2 into S minus B, right? So how can we solve this further? 2 into S minus B. 2 into S minus B. Okay, so we'll have 2 outside. S is A plus B plus C upon 2 minus D, right? We'll take LCM. So we'll have A plus B plus C minus 2B, the whole thing upon 2. This 2 and this 2 cancels out. Okay, and then we are left with plus B minus 2B, we are left with A plus C minus B, which is A minus B plus C equal to the right hand side. Okay, I'm going back to the question. Let's check the question again. So what is the question? 2 times A sine square C upon 2 plus C sine square A upon 2 is equal to A minus B plus C. So what have we made use of over here? We've used the Heron's formula for half angles. That is, sorry, or you can say half angle formula. Sine C upon 2 is under root of h minus b h minus a upon ba, and sine a by 2 is h minus b h minus c upon bc. It's a square term, so the root is not there in the question. Okay. Then we solve it further, and what is the final product that we get? We're getting a minus b plus c, that is your RHS. Okay. Only thing I have not mentioned over here are the formulas. When you are solving the sum, please make a note of it. Please write the formulas while solving the numericals. Okay. In the next session, we'll complete this exercise and then we'll go on to inverse functions. Thank you very much.